I'm Officer Cadet Martinez Chung, and today we're going to learn how lift is created. First, we're going to go over airfoils. So what airfoils are is a surface designed to obtain lift. That is essentially what an airfoil is. There are different types of airfoils with different shapes and sizes. However, for the purposes of this course, you don't need to know every single shape. We'll just divide it into two basic shapes, which we will go over in a future lesson. One thing to remember about airfoils is they have that classic curved shape, and that's how they get their lift. So, camber. Camber is what we call the curvature of the upper and lower surfaces of the airfoil. So usually the upper surface has greater camber than the lower. This creates the pressure difference that allows us to generate lift. Equilibrium. So when two forces are equal and opposite, then the aircraft is said to be in a state of equilibrium. So for example, let's say we have thrust and drag. They're both opposite, right? Now if they're both equal, then the aircraft will continue to move forward at a uniform rate of speed, right? It will not accelerate or decelerate. Right? Equilibrium here refers to steady motion. Right? For the purpose of this course, however, a state of rest is not considered equilibrium. Okay? So when either of these forces become greater than the force opposing it, so for example, let's say we add power to the engine, thereby increasing our thrust, then the state of equilibrium will be lost, because at that point we will be accelerating. Alright, lift and weight. So when lift and weight are equal and opposite, the airplane will be in equilibrium, which we just discussed. However, if lift is greater than weight, then the aircraft will climb. Then vice versa, if weight is greater than lift, then the aircraft will sink. Right? Same thing with kind of thrust and drag. So thrust and drag are equal and opposite, they're in equilibrium. When thrust is greater, so we add more power, the airplane will accelerate, it will gain airspeed. If drag is greater, so let's say we're reducing the power to the point that drag overtakes it, then the airplane will decelerate and lose speed. Alright, couples. So these are the couples you see in everyday life. Hashtag forever low. These are aerodynamic couples. Alright? So when we have two forces that are equal and opposite, the airplane is said to be in a state of equilibrium, right? However, when two forces are equal and opposite, but they're parallel, as in they go right beside each other rather than to the same point, then they are said to form an aerodynamic couple. Right? This aerodynamic couple will cause a turning moment about a given axis, or usually the C of G. So what this means essentially is if thrust and drag are not going to the same point exactly, one is above, one is below the other, then what will result will be a turn, either a pitch up, pitch down, any sort of turning motion. Alright, so for example, let's say weight is ahead of lift. Right? In this case, the couple created will result in the aircraft nosing down. Alright? Because as you can see, we have the force of weight is pulling it down while the force of lift is pulling up, all around a center point, which is between the two forces. Right. Likewise, if we have lift that's ahead of weight, then the couple created will result in a nose up. Alright? Because again, with lift being ahead of weight, the resulting motion will be a turn. Alright. Next we have drag above thrust. In this case, the couple form will result in a nose up. Again, emphasizing that since drag is pushing forward, thrust is pushing forward, drag is pushing back, but since one is above the other, then that will result in a turn, or in this case a pitch. Alright? And vice versa, if thrust is above drag, and the couple form will turn the nose of the airplane down. Alright, moving on, we have what we call the relative airflow. So the relative airflow is a term used to describe the direction of the airflow with respect to the wing. So from the point of view of the wing, so let's say you were a wing, and the direction the air is coming at you is the relative airflow. Okay? This relative airflow changes depending on the direction of motion, not necessarily the pitch angle. So that you could be at up 90 degrees pitch, moving forward, and the relative airflow will still be coming in this direction. Alright, streamlining. Streamlining is something we had discussed earlier in earlier lessons. So this just means changing the shape of a body so it's smoother and minimize drag created by the body. Aileron drag. Alright, so this is a very important thing to know, especially when it comes to flight training. Alright, so what happens when an aircraft makes a turn, one aileron is raised and the other one is lowered. Alright, so usually what happens is, let's say we're turning to the right, then that means this aileron is going to go up, this aileron is going to go down. Okay? So what you're essentially doing is, as you roll towards the right, then you're making the right wing produce less lift and the left wing produce more lift. However, you have to remember, whenever we have more lift, we also get more drag. So going back to our airplane, then the left wing, which is producing more lift, is also producing more drag, while the right wing is producing less lift and therefore less drag. And the result is a yawing motion, opposite direction you'd want to go. Okay? If you actually try it in an aircraft, it's kind of tricky. You notice the roll, and suddenly the aircraft will yaw a little bit and then right itself back. Okay? One way to correct this is using the rudder pedals, or the rudder. That's when we have yaw. So that's why whenever you add roll, you always add a little bit of rudder in order to counterbalance that aileron drag, or what we call adverse yaw. Alright, next up we have lift and drag curves. So this part of the material is actually a little bit advanced, so you do not need to know this for this course. But just note that the amount of lift and drag created can depend on a lot of factors, including the shape of the airfoil, the wing area, the square of the velocity, and the density of the air. However, you do not need to know this. It's just a FYI. Alright, same with this slide over here. So as you can see, we do have a formula which we can use to calculate the amount of lift and drag created. However, this goes beyond the scope of this course. Now, lift to drag ratio. This you need to know. So what the lift to drag ratio is the relation between lift and drag. So this is obtained by dividing the amount of lift you're creating with the amount of drag you're creating. And then we get our ratio. Now, why this is important is because we have what's called the best lift to drag ratio. Alright? This reaches its maximum at 0 degrees angle of attack, and this is where you get the most lift for the least amount of drag. Now, usually this is commonly known as a best glide speed. Right? So this is the angle of attack, and therefore the speed you want to fly whenever you have an engine failure. At that point, you're creating the most amount of lift with least amount of drag. Therefore, you will go the furthest distance without losing as much altitude. Alright, and that's it. So if you have any questions, comments, concerns, queries, or random outbursts, feel free to post them in the comment section down below. Thanks for watching, and happy landings!